I am hoping to not repeat problems that I've already put out there. Unless you watched it and didn't know what I was doing, then I will do it again. But the goal is to get through as many new problems as I can that you're not sure about. So if you look there on your screen, I'm going to go over 2.5, which I've covered almost all of those already and put the videos up. 2.7, I've done a few of those, and then 2.8 and 2.9 I've not done yet. We're having a quiz Monday and Tuesday, depending on what day you're here, over 2.5, 2.6. And then on Wednesday, Thursday, we're doing the 2.8, 2.9 quiz. And then the week after this, we're going to be doing the Unit 2 test. I'm going to do it a little differently than I did the first time. Right now, I'm planning on doing both free response questions the same day with the first 5 multiple choice with a calculator. And that way, we're only going to have about 20 minutes of the next day where we have to, about 20 minutes of the next day where we'll spend on finishing the test, and then we can start Chapter 3, Unit 3. And when you come in Monday, remind me, I'm going to pass out all of Unit 3 to you guys on Monday. All right, so we're going to start with 2.5. So if there's anything on each page that you need to see that you're not sure what happened, and I'm hoping that you already watched the videos, that you will ask to see them if you're not sure about something. So here's the first page on the circuit. Does anybody have anything on this front page? Like you can say left side, third one down in a chat. You can do it to me privately, or you can chat it to everybody. If I don't see anything here soon, we'll go on to the next page. Okay, the second page on the circuit. Are there anything on this one? Anybody? All right, I just now saw bottom right. Is that on the front page or the second page? Second. All right, the bottom right problem on the second page. We're going to come down here and do that. Okay, now this one, we're going to learn in Unit 3, we're going to learn a way to do this differently. And that does say x minus 5 to the third, I believe. So this is a cubic. Now you can, I don't recommend it, but you can take this thing and write it out 3 times and multiply it all together, FOIL the first 2, and then do triple distributive into the last one and get the equation. But there's a faster way to do this, and it is called using Pascal's triangle. So Pascal's triangle looks like this. You got the diagonals going up from the top. They make a triangle, and they're ones going all the way down. And then the 2 numbers above, you add the 2 numbers together, and they go in the middle. And then so you put another 1 here, and 1 plus 2 is 3. 2 plus 1 is 3, and you get a 1 here. And you continue this pattern forever. And this is a shortcut to doing a binomial to whatever power you want. This power right here is the binomial to the 0 power. Okay, so that always equals just 1. And then this is a plus b to the first power, and this would be to the third power. If you remember, you square the first, square the last, first times second, that times 2, that's where that 2 comes from. And we're doing this one. This is an a plus b to the third power. So we want to use this line right here because it's a cubic. So these are the coefficients of each thing we do. So when I come down here and do this, y is going to equal, and I take that coefficient of 1. Now I usually wouldn't write that, but I'm just showing you where everything's coming from so you can see it. So I take that 1 from Pascal's triangle, then you come over here and you multiply whatever the first term is, which is that x, and you raise it to that power. And I usually wouldn't do this part either, but I'm going to today. So that's -5. You take the second term, which is -5, and you raise it to the 0 power. So I usually wouldn't put this one here or this one here because they're both 1. But I want to show you the pattern. I'm going to go to red because I'm going to have to go too far over here. Then I go plus, and I go to this second number up here, this 3, and I put the 3 down there. And then I take my first term and I lower that power by 1. This was 3, so this becomes 2. And then you take the second power and you increase its power by 1. That's 0. This is 1. If you notice, when you add these powers up each time, they will be whatever this power is over here. So we get that. And then we continue the pattern. The next coefficient is that 3. And then I lower the power by 1 of the first term, increase the power of the second term. And then last, I take this 1. And I probably wouldn't even write this x to the 0 here because that's 1. And then I take -5 to the third. So when I simplify all this, this will be my y. So this is x cubed. This -5 times 3 is -15x squared. -5 squared is 25 times 3 is 75x. And -5 to the third power is -125. So there is my cube without having to FOIL. Now you can FOIL this, add like terms, triple distributive, you will get this same answer. Now we do the derivative. So we get the derivative of y will be 3x squared. I'm taking 3 times 1 and lower that power by 1. 2 times -15 is -30. Lower that power by 1. If you want to put a 1 there, you can. 1 times 75 is 75. Lower that power by 1. And there's a 0 times that is 0. So this is my derivative right here. Anything else on the second page or any questions on that problem? Okay. Third page. Anybody got anything on this third page you'd like to see on 2.5? Okay, I see nothing on that page, so we're going to go to 2.7. 2.7 here. Does anybody have anything on 2.7 you'd like to see on this first page of 2.7? This is doing the derivative of sine, cosine, e to the x, and natural log of x. I hope you watch those videos. Again, I want to emphasize to you that it would be a great idea for you to make flashcards on these rules. They're all on that sheet of paper I gave you that I hope you got on the front. Okay, we're going to go to the next page.
Mr. Woodrow?
Yeah.
I have a question about the flashcards and how you recommend them. So for you said you recommend creating flashcards. Would you put like D over, for the first basic rule that we have?
I would do this. Like if I'm going to do the derivative of sine over dx, derivative of sine. This is the derivative of sine of x dx. And this dx in the bottom means with respect to that variable x. And then on the back side, I would write cosine x.
Okay.
So you see you're doing the derivative of sine x dx. On the back, you see cosine is the derivative of that. And then on a different card, I would put the derivative of cosine of x dx. And then put negative sign on the back of that card. So that's what I would recommend you do so you can look at these. And then believe it or not, later on, these might help you because we're going to do integrals later, which is kind of the exact opposite of doing derivatives. Does that help?
Yes, thank you.
Okay. All right, anybody got any questions on this second page from 2.7 that you want to see? Okay, I'm going to go on to the third page of 2.7. This one is a shortcut on doing derivatives. I hope you watch the video on this. This is something, you're going to see something like these questions on the AP test. There'll be multiple choice questions, and they're going to ask that you're got to know when you see this that they're asking you to find a derivative. And then you use the shortcut. You use those things you're doing on those flashcards that you know, and then you don't have to go through all that limit stuff. That's a pain in the rear end. And we're also going to learn another shortcut later on called L'Hopital's rule. But you can't do L'Hopital until you know how to do all the derivatives. Nothing on this page? All right, let's go on to 2.8. Okay, so 2.8, I think I got one here. Yeah, this is product rule and quotient rule. Pretty big deal that you know these. These are going to be on the AP test in different places. 12H. Is this the 2H section, the person that put 12H on there? Two seven. All right, we're going to go back to 2.7 and do 12H. So 12H. So what I'm looking at is I want to figure out of all these things, which one of these up here does it represent? This thing right here is the definition of a derivative. This first thing, definition of a derivative. And then this is an alternate form of the derivative. If you look, the only thing difference from this first one to the second one is they've changed x's to c's. So what that means is the C represents saying they've put a number in for the C. That's what this C is. So instead of X, they put a number in for both of these. And then this is the alternate form that you're going to see the most. This is different than those. If you notice, these both are as the denominator is going to 0. Okay, so that's a good clue to you. And then these will be as X is going to whatever this number is. So when I come down here and look at 12H, 12H, now do you see how there's only one thing here? See, this one over here is the third one because it's got X minus 2. This one right here, because they put a number in here, they put the numbers in here, and they've got one term here. This is the middle one. This is the middle one at the top. Now, what I want to get from this is, first of all, I can see that they put a 3 in where the X goes. So that tells me that C is 3. And if you go back up there and look at that one, wherever the C was, over here is where the X goes, right? So this C and this C is where the X goes. So what I do down here and looking at this problem is, I think, okay, I know that's an X and that's an X. And then the difference between f of X and these on the original problem, the only difference between this one and this one is they've added delta X. So if I come down here and I get rid of the delta X, that tells me this is f of X now. So what that tells me is that f of X is equal to X squared plus X. Now there's a way to check to see if that's the right thing is plug this 3 in here because this is minus f of X. And if I plug this 3 in here and get 12, then I know I'm right. So 3 squared is 9 plus 3 is 12. So that's where that comes from plugging that into the function. So now that I'm here, my goal, I hope you know that this is telling me what this thing means right here, going back to this thing right here. And if you go back up, maybe I should have done it at the top. If we go back up here to the top, we're looking for the derivative of f at that C value. So what this is telling me I'm looking for here is I am looking for f prime of 3 is what I want to find. So I'm first going to find f prime of X. So I take 2 times 1 and get 2x, lower that by 1 is 2x to the first. Take this 1 times 1 and get 1, and when you lower that, the x is gone. There's my derivative, but I need to know that this is asking me to find the derivative, which is the slope when x is 3. So I plug that in, and I would stop right there. That's what I would do for my answer because some people make a mistake when they simplify that. Now, I did a video on this yesterday, but I think these are really important to see what they are because these make these limit problems really easy once you learn your derivative rules. Okay, going on to the next page. This is 2.8, product rule first. Does anybody have any of these they want me to do on 2.8 on the front page? Now, I want to tell you something else that I told that every time I did product rule, when you have 2 terms, when you are doing 2 terms, okay, when I do this problem, I said the same thing. I think I said it every time I did it on the video. And you should learn it and say it to yourself every time. This f of X is the first term. This g of X is the second term. So every time I did this, I said first, and maybe you need to auto write it down. First term And then I say times derivative of the second term. So that would be g prime of x plus the second term times derivative of the first term. So the second term is g of x, derivative of the first term is f prime of x. So every time I do this, I say this out loud to myself. So I'm going to do problem 4 here. Now you cannot do a derivative when it's in radical form. So the first thing I'm going to do is rewrite this not in radical form. So when I look at this problem right here, this t to the half, this is my first term. This 1 minus, oops, I wrote the 2 in the wrong place. This 1 minus t squared. This right here is the second term. That's the second term. So when I find the derivative of this, I take the, I'm going to go through this thing right here. I get first term times derivative of the second term. Made that a little too wide. So the derivative of 1 is 0. So I do the derivative of this is 2 times negative 1 is negative 2. Lower the power by 1. That's the derivative of the second term plus the second term. So I write it down just like it is. Times the derivative of the first term. So that is a half times t to the negative half. So that is my derivative. Something you ought to notice here is pretty much every time we do a derivative, we get a more complex problem every time we do a derivative. Okay, now this is the answer. Right now, I'm worried about you being able to write it like this. This is the big deal, that you can write it like this. Okay, so I would practice this tremendously. Now, I'm going to show you what we need to be able to do later, and that is factor this thing. So you might want to practice this, because this part is kind of hard. So I hope you can see that this plus sign is separating the two parts. So I'm looking for the GCF. I'm looking for the GCF out of these two parts. Okay. Now, I would take out a half and the t to the negative half because that's the lowest power. So when you take out a half, that means you're dividing by a half, and I'm dividing by t to the negative half. I am factoring that out, just like if I had 2x plus 6x squared. If I took the 2x out, I am dividing this 2x by that 2x, and we get 1 plus 3x, because I'm dividing 2x from this one as well. So I'm dividing a half out of here. So if I divide a half out of this thing, that actually makes that a -4. Because when you take -2 divided by half, you flip it upside down and multiply it. Now, when you factor out an x, you subtract. You take the exponent here minus the exponent you're taking out here. Well, I'm taking out a negative. So when I take a negative half out of this, I'm actually adding a half to this because it's a half minus negative a half. So that would be a t for this. Now that's kind of tricky. And then I also have this t. You know what? I should have done something else different. Let me go back and do this again. I should have gone ahead and written these two together. So let's do this first. So I should have said this t times t to the half is t to the 3/2. This would have been better to do it this way. And then over here, I've still got this same stuff, but I'm going to put the monomial in front. Again, right now, the big key thing is this first line. So again, I would take out 1/2 t to the negative half. That's this thing. I'm taking out of both of these. So I'm dividing that by 2, so that's -4. And I'm taking 3/2 minus 1/2. That's 4/2, which is 2. And then I took this whole thing out. So what I'm left with over here is this plus 1 minus t squared. If you put the parentheses there, it's not wrong. And then these two are like terms. So I would rewrite this as 1/2 t to the, actually I'm going to move that t down to the bottom and put it back in a radical. And then I'm going to combine like terms over here. And we want to be able to factor this thing up here into this form. That's going to be a big deal later. So you want to try to start practicing this. But right now, what I want to make sure you can do is this part. This is the biggest deal up here. If you can't do this at all right now, it's okay, but you have to be able to get that part right. And I will take that part as a correct answer right now. But on the multiple choice part, he may be writing it down like this. So you want to try to practice that. Now that was a long time on that one problem. So I know it was, but I will do the rest of them a little more quickly. I wanted to get into some big details. Anybody got any other problems on this page you want to see? Okay, I'm going to get to 2.8 in a minute. We're gonna go through all these. I'm going to go to the second page of 2.7. Anybody wants to, now this is quotient rule. Does anybody need to see any of these quotient rule problems?
Mr. Woodrow, we are on 2.8.
What?
This is 2.8.
Oh, my bad. Sorry. You said 6. My bad. I thought we were on 2.7. So, all right, we're going to come down here to 6. Okay, well, this one down here is 2 product rules. Because they're separated by that plus sign. If you look, I got to do product rule twice because this 2x, that is the first term here, and then this sign, that is the second term. And then when I come over here, this is the first term, and this e to the x is the second term. So I got to do product rule twice on this one. So when I do this problem, I'm going to move it over because they get longer as you do them. I hope I got enough room putting it here. So I'm going to do the derivative of this. So the first term is 2x, so I leave it the same, and I do the derivative of sine, which is cosine x. Okay, then I do plus, and then I do this second term, which is sine x, times the derivative of 2x. Now, I could put the 2 out here, but that's going to end up being the coefficient of the sine. So I'm going to go ahead and move it to the front of here. So this 2 goes here. Then I got the plus sign. So this right here, this part right here that I just did, that part is the derivative of this part, of these two things. Now I got to do the same thing out there. So that plus sign there is this plus sign here. Does that say x squared or x cubed? I can't see. Somebody unmute and tell me.
Squared.
X squared. So then I do the first term, which is x squared. And the derivative of e to the x is still e to the x. And then I get plus the second term is e to the x, leave it the same. And then it's times the derivative of x squared, which is 2x. And again, you can put the 2x here, but I would, my next step is I would move the 2x in front of e to the x. It would not be wrong if you didn't. So you can do this whole big long thing here. That is what we're working on right now. We need to be able to find that derivative.
Please pardon this interruption.
So now,
46 a.m. on September 11th, 2001.
if you
Airlines Boeing 767 Flight 11 collided into the World Trade Center's North Tower.
if you would look at this thing right here, I can factor out a GC. Let's see. No, there is no GCF in all of them.
18 minutes later.
So this right here would be what we'd want to stop at right there.
Airlines Flight 175 flew into the
Okay. How about the second page?
About 30 minutes later,
Anybody got anything on the second page?
crashed into the west side of the Pentagon near Washington, D.C. And a fourth plane, United Flight 93, crash landed into a field.
Again, this is quotient rule.
Killing all 40 people on board. Meanwhile, both the World Trade Center towers collapsed. More than 3,000 people, including more than 400 police officers and firefighters, were killed, and more than 10,000 others.
Okay, number 11.
The attacks on 9/11. September 11th is now known as Patriot Day. In the United States, it is observed as the National Day of Service and Remembrance for the victims of the 9/11 attacks. Across the country, numerous events are held on this day to honor.
All right, so this problem, you got a couple options. You can take the 3 and distribute it,
This year's remembrance is
or we can take the 3 and the 2. What I would recommend doing is taking the 3 and the 2 and looking at those as a coefficient. Because coefficients, you just leave where they are. So I'm going to only need to do the derivative of that part. Now, I told you that when you do a derivative, I'm going to say it again. Now, I know I told you on the, I know I told you what to do on the video about how to do this problem. So what the video showed you is you take the bottom. I hope you see that that cosine is the bottom, and then this 1 minus sine is the top. So I take the bottom, and then it's the bottom times derivative of the top. So the derivative of 1 is 0. The derivative of sine x is cosine x, but since you got a -1 coefficient, this is negative cosine x. And then it's a minus, and it's minus the top. So you put the top just like it is, 1 minus sine x, and it's divided by, and it's times the derivative of the bottom. So the derivative of cosine is negative sine x. And then it's over the bottom squared. So down here on the bottom, we would put cosine squared x. Again, that is the big deal right now, that you understand how to do that right there. Bottom derivative of the top minus top derivative of the bottom over the bottom squared. So make sure you get that down. You want to write it down. You want to, I say it to myself every time. There's a saying that some people use, which is the same thing. They call the bottom the low and the top the high. And they say low D high minus high D low over low squared. So low means the bottom. D high means derivative of the top minus high D low, the high, the top. Derivative of the bottom is the D derivative bottom. So whatever it takes for you to get it. Now we're going to simplify this, and you should practice this. So this times this would be negative cosine squared. And then I got a negative times a negative. These two negatives end up making both these positives. So then I'm going to have, distributing this, I'm going to have plus sine x minus sine squared x. And then on the bottom down here, I have cosine squared x. So I'm going to go through and show you how this simplifies, because, by the way, this first line, that's all calculus. Calculus is all over. This is not calculus anymore. This is trig, simplifying trig stuff. So if you look here, we have a negative in common with both of these. So I would factor a negative out of both of those, cosine squared and sine squared, and I would rewrite it as a negative cosine squared x plus sine squared x. And then I have plus sine x. And down here, I still have cosine squared x. Then, I hope you know cosine squared plus sine squared is 1. So this is going to be -1 plus sine x. And I hope you know from your Pythagorean identities, this down here is 1 minus sine squared x. So this is 3/2. I'm going to flip-flop these. Yeah, I think I will. Well, I'm going to leave them the same. This is a difference of squares on the bottom. I'm going to factor a negative out of the top, and you'll see why here in a second. So I take a negative out of both of those. And then when you factor that difference of squares on the bottom, you get 1 plus sine x and 1 minus sine x. So I hope you see that these 1 minus sine x's reduce. So you got a negative. I'm going to take this negative all the way out here with this 3/2, negative 3/2. And I guess we could just extend that out and have 1 plus sine x. That is probably, this is probably how they would write that answer. They'd probably put the 3 more in the middle though. But this would be this is where they would simplify this big long mess to up here. But again, right now, the key is knowing how to do this part. That's the part I want to make sure you know how to do for now. All right, I've also got number 12, so I'm going to do 12, and then we'll go from there. Okay, this is a complex fraction. I would never do a derivative when it's still in complex fraction form, so I'm going to get rid of the complex fraction, just like we did when we did the limit stuff. So I'm going to distribute x in the top, and I would get 2x minus 1. I distribute x in the bottom, and I will get x squared minus 3x. And now I can do a regular quotient rule with that. So when I do this quotient rule, I do bottom times derivative of the top minus the top times derivative of the bottom. And because of time, I'm not going to simplify all this. And maybe I should. Yep, I am going to, sorry. So this is x squared minus 3x. Okay, so what I want to show you is I am going to factor this part. I'm going to factor out a GCF here and a GCF here, and I think you'll see why in a minute. So I'm going to take x out of that, and it's x minus 3x. And I'm going to take this 2 and move it to the front with that. So this 2, I'm moving to the front. And then over here, I've got 2x minus, whoops, this should just be a 3, not an x, my bad, because I factored the x out. Come on. And then I got my 2x minus 1, and I have 2x minus 3. Okay, I thought I was going to be able to reduce some stuff, but I can't. Okay, I can't reduce it, so I'm just going to leave this like this. So what you could do is you could go ahead and FOIL these two, distribute the two, combine like terms, and all that good stuff is what they would do. So right now, again, what I want to make sure you, oops, I forgot to put the square here. Somebody should yell at me. It's the bottom squared. I forgot to square it. So make sure you can do this. Again, bottom, derivative of the top, minus top, derivative of the bottom over the bottom squared. Okay, next page. Anybody got anything here? This is doing the same stuff. Find the derivative. Anything on the back page? You want me to do a tangent line down here at the bottom? Find the tangent line using these rules? Okay, I'm going to do 17. So 17 wants me to find the equation of a tangent line. This is so huge. This is going to be all on the AP test and your test coming up. So equation of tangent line. Anytime you need an equation of a tangent line, I need you to be thinking that I need to get a point and I need a slope, and I'm going to use point slope form. Now they happen to give me the point. There's my point right there. So I need to find the slope at this point. So f prime of x is going to be, this is quotient rule, bottom, derivative of the top, minus the top, times derivative of the bottom, all over the bottom squared. Now, I would not simplify this. Remember, you cannot have any variables in your slope. That is the slope to every single point on that original graph. But I only want the slope at one point, and that's at 2, 4, which means I want to find the slope when x is 2. So I would come in here and plug in 2's to all these x's. And here I'm going to get 1 times 4 is 4 minus 4 over 1. This slope is 0. I wish he wouldn't have given us a 0 slope, but he did. So you could write this as y minus 4 equals 0 times x minus 2. You can leave it like that. You could also go ahead and say 0 times this whole side is 0, and y equals 4 would be the equation of the tangent line. Anybody else have anything on this 2829 part? Is it that, oh my goodness, you are correct. The denominator is squared. Thank you. I did it twice. That is by the way, that is a common mistake. It didn't have to change this answer because 1 was my denominator when I plugged it in. But yes, that you do have to square the bottom. So I should have had that there. And dropping that square is a common mistake my students make. So thank you for catching that. Appreciate it. Anybody else got anything? Nothing? Okay, you might want to check later because like I said, I'm going to make these videos all day long, and I'm going to try to not do these same problems so that you can see other problems done. So other classes may like ask for 17. I'm going to say, hey, I did 17 during second period, so I'll do 18 during this period. And that way you can see a video of that if you have trouble with it later. Again, Monday, we're going to have a quiz. On Monday, Tuesday, quiz on 2526. And then Wednesday, Thursday, we're having a quiz over what I just showed you, the 2829. And we're going to be working on the practice test all week. And I've got a little thing in class I'm going to have you do with a partner, which is kind of neat. Should help you know if you're doing it right. So I guess I will be signing off. I will see you guys Monday. Have a great weekend. Stay out of trouble. Do what's right, not what's popular. And I'll see you guys Monday.